See this is a problem, you can say it's the application of complex number in the geometry, right? If we do in that form, this is a very simple problem. But before that, before going to this problem, right, let's discuss a basic theory and then we'll come back to this problem, okay? So let's go ahead. So in this case, we'll start our discussion of the problem with the equation of a circle, okay? So let us consider a circle, okay? So what is the equation of a circle? We all know that. So equation of circle is actually x minus alpha whole square plus y minus beta whole square, and that's equal to r square. So what's the condition here? For this problem, the circle, the center, it's definitely the coordinate alpha beta, and the radius of this problem, so that we all know, okay? So now try to represent it in a complex number, okay? So that's why we consider that z is equal to x plus iy, and let us consider a number a, that is alpha plus I beta. So why we consider that? Because we know that, right, that any point in the circle in a coordinate sense, right, in the real number is x comma y, and that also in, if we compare with the Argand plane in the complex number, that is x plus iy. Alpha beta is the center, that can be considered as alpha plus I beta in the form of complex number. Now let us try to calculate mod of z minus a. So you can see that that gives you mod of x minus alpha plus I into y minus beta. So what is this mod? This is actually, will give it as square root of x minus alpha whole square plus y minus beta whole square. Based on the equation of the circle, this is r. So therefore, we'll say that the equation of a circle in a complex field is actually mod of z minus a is equal to r, where a is the center and r be the radius. So that's the problem. Okay, so if we use this concept, the problem can be done in a second, okay? So let's go ahead. So here we have two complex numbers, z1 and z2, satisfying the given equation. So therefore, we can see that mod z1 equal to 9 imply that it's actually a circle with center 0, 0. So we write center maybe c1, and that is 0, 0, and radius r1 is equal to 9. So this is the complex number. Now when I say that z1 means 9, that z1 is a complex number lies in the circumference on a circle of the center c1 and radius r1. Now we consider the second complex number, that is z2 minus 3 minus 4i. So z2 minus 3 minus 4i is equal to, I guess it's given as 4. So obviously we can compare it that it is actually a circle, right, with center 3 comma 4. Why? Because you can see that it is z minus a. So if I can take in the minus 1 common, it is 3 plus 4i. So therefore it can say that it's actually represent, or the point z2 lies on a circle with center 3 comma 4. So let us consider it is 3, 2 and lies in 3 comma 4, and we have the radius 4. Now we have that C1, C2, 2 center and 2 radius. So let us find the distance between C1 and C2. So what is C1 and C2? So C1 and C2 is actually square root of 3 square plus 4 square. That's actually 9 plus 16 is 25, so 5. So distance between the two center is 5. And also you can see that it is actually equal to R1 minus R2. So C1, C2 distance between the two center of the circle is equal to the difference between the radius. So what that means? It means that both circles touch internally. So that's it. So that's the problem. Okay. So, and we'll say that ends the problem. So let's have a look on that. Okay. So we have a circle C1 and a white circle as you've seen. So what's that? This is actually that white one. According to that, the Z1 lies. So any point on that white circle, Z1 lies. And if I consider the second circle Z2, which are having a center C2, where Z2 lies. So we'll see that as they touch internally, there will be a point which is here that intersected both the circle or touch each other. So at that point, Z1 is equal to Z2, right? Because they touch internally. So therefore, we'll say that at point of intersection, or you can say where the touching point, the same thing, point of intersection, Z1 is equal to Z2. Now at this point, as Z1 equal to Z2, so therefore the Z1 minus Z2 mod, that is the distance between the two complex numbers Z1, Z2 will be 0, and that's the minimum value here, right? So therefore we'll say that minimum of mod of or the distance between Z1 and Z2 must be equal to 0 because they are same at the point of intersection. So at the point of intersection, this distance will be minimum and the minimum value is 0. Therefore, for this particular problem, option D is the correct choice. Hope you understood the problem. So let's have a look as obvious in detail the proper writing and all that stuff. So you can copy it for your note. Hope you understood the problem. Thank you.